Okay. That's our first one. And the other quartiles are similar. So the process is similar, that is. For Q2, which again is the median now, okay? I know we did a different process for finding the median, but what we're doing here is actually very similar. It's equivalent, actually, I should say. That's a better word. It's equivalent. Not identical, but it's equivalent. The median, the difference now is your L is 0.5 times 14. 0.5 times 14. 0.50 times 14, in other words. Now notice this is a whole number, though. This is a whole number, though, okay? So what does that tell us? Well, this number 7, we're going to use this what we do. We find the 7th data value and the 8th data value, okay? The procedure, again, is in the previous set of notes, which I emailed you guys, everyone. So we use the 7th and 8th data value, okay? And we take the average of them. So I know the answers are here, but let me show you how to get it from here. 1, 2, 3, 4, 5, 6, 7, and 8. So 6 and 7 here. 6 is the 7th data value. 7's the 8th data value. So we take the average. What's the average of 6 and 7? 6 plus 7 over 2, which is 6.5. Okay. So that's what we have. Notice also that the median is actually not a data value. That can happen with these quartiles. They may not be data values. Q3, okay, as you can see here, Q3, this here, what we do now for our locator is 0.75 times 14. 0.75 times 14, which is, of course, 10.5 once you do the calculation. Now, again, this is a decimal, so we round up to the next whole number. Go up to 11 in this case. That's the next whole number. The 11th data value is our 3rd quartile. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 10. So 10 is our 3rd quartile. And again, what does this mean? Well, this means 75% of the data is below 10. The median is 50% of the data is below the median. And for the 1st quartile, 25% is. So this 5-number summary, we can make a box plot. I'm going to show you how to make it. I'm going to make it in Desmos, but this is what we would get. But let's make it together. That is, let's go to Desmos and make it. So let's see, here's the data, okay? So what I'm going to do is make it in Desmos. So let me stop this. Let me get to Desmos now. Chrome tab, box plot, next, okay? So let me open up, let me see, I think box plot 2, here it is. That's the one I want to open up. So let me type this in with you guys. So yep, you can see it, good. So again, I'm going to type in the data now, okay? So we have 2, 3, 3, 4. So again, notice what I'm doing. I'm calling this L. You can call it L, then a 1 if you want, or just L if you want. Equals, so make it 1. We put these square brackets, not the curly braces, square brackets. And now we type the data separated by commas. So we have 2, 3, 3, 4, 2, comma, 3, comma, 3, comma, 4. See, we have 4, 5, 6, 7, 8, comma 4, comma 5, comma 6, comma 7, comma 8, 9, 10, 11, 9, 10, 11, 14, 16. Notice also it tells you how many elements are in the list. That's good. That's useful. Okay, so I type the data in. Then I go to box, I type in next, box plot, parentheses. I put the name of the list, L1. It subscripts it for you, just letting you know. And also, let me uncheck this so we can see all the data. Okay. Move it over here, like so. Now, everyone, you can see it. We get this box plot. We get the box plot. So I'm going to zoom in a bit, okay? Again, I can make this disappear by clicking these double arrows. Now, if we zoom in, okay, good. We can see now that the minimum, okay? Yeah, the minimum, as we can see, is 2. The maximum is 16. Okay. We have 4 as our Q1. The median is enough, 4, excuse me, that's our first quartile. The median, we calculated it to be 6.5. The Q3 we got was 10, third quartile, okay? And then our max is over here. So again, it's just a way of seeing the data, that's all. You know, excuse me, just a way of seeing how spread out the data is. That's all. All right, that was fun. Okay. Are there any questions about that? Okay. And let me just say this, you don't have to actually do this, but I mean, it is useful. If you make an account, you can make an account here with Desmos, and then you could save the graphs you make. And it's actually, if you have a Google account, like a Google email, it's free to do. So it's free to do, which is nice. Do you have to do it for this class? No, but you know, just letting you know. All right, anyway, so let me stop sharing this. Let's get back to the notes. Okay. I figured we'd do a few more examples. Then what we'll do next is start chapter 12 today. And chapter 12 actually is the last chapter. I mean, I do know that we have next week. Then we have the week after Thanksgiving break. And that's our last, I think, week actually. I think our last class, I think, is December 3rd. So, and I think some people have asked this. What I'll do with the final, it's going to be the same format as the exams, the final exam. So what I'll do is, you know, I'll post it on Blackboard a few days before the final is actually supposed to be given. Supposed to be given, that is, when, how do I say this? It'll be a few days before the final exam, according to the final exam schedule, like on Oneonta. And you'll have a few days to do it, and it'll be due when the final exam would be given, if it was in class. I hope that makes sense what I'm saying. I mean, I'll let you know when it's posted, and you'll have a few days to do it. So, okay. It'll be take home. It'll be the same format. I don't want to make the final a new format because I just think that would be very unfair. So that would not be fair at all, I think. So anyway, all right. Okay, let's do this example. So this one I actually got from the book. Figured it'd be good practice. Okay. So let's suppose now that 65 randomly selected car salespeople, okay? You know, for whatever reason, we ask them how many cars they sell in a week, generally. You know, like at a dealership or something, you have those people that sell cars, those things. And it turns out, you know, you have this data that 14 of them said they sell 3, 19 of them generally sell 4, 12 of them sell, 5. Let me see, 9 of them generally sell 6, and 11 of them generally sell 7. Okay, so that's our data. And now what we want to do is somehow get the 5-number summary for the data. The actual data that we're going to deal with is how many cars these salespeople sell. Okay, well, why don't we organize it a little bit more, right? I mean, you could work directly with the word problem, but I want to have my data more organized. And that's why I make a frequency table, right? We have 65 people in the sample. And again, the data values is the number of cars that are sold per week, you know, what the sample people are telling you. So 14 people sold 3, 19 of them sold 4, and so on. So we made a frequency table. Now, you could actually theoretically list all the answers by each person, you know, one by one. So like the first you can list like, okay, you can list like this person said 3, this person said 3, this person said 3, then you keep going and this person said 4, this person said 4, but I thought this would be a lot easier using a frequency table. You know, there are 65 people in this sample. I don't want to make 65 rows in a table, so that'd be kind of cumbersome. Be annoying. So that's what we have, a frequency table. So what we're going to do is get the 5-number summary for this frequency table. I mean, I guess theoretically you could get it by a box plot, but, you know, by graphing it, but let's do it by hand because that's more fun. Okay. Let me just get to the